When we study the behavior of certain types of functions and graphs, it helps to know something about symmetry. So there's three different types of symmetry that we're going to discuss. The first one would be symmetry about the x-axis. So here would be the x-axis. So what we mean by that is you can actually take, for instance, this red graph here and imagine that this is a piece of paper that you can fold on this line here, on the line, the x-axis. You're going to end up being able to say that this piece will lie exactly on top of this piece. Now, if that occurs, what you've got is x-axis symmetry. And you can see that also happens with this graph here. Okay? Now, but what if I took this red shape and had this green graph? The shape is the same, but the fact is it's been moved up by a certain amount off of the origin. So if you folded along this line here, you wouldn't be able to match up this side on top of this side. Okay, so because you've got this distance right here, this graph, this green graph, is not symmetric about the x-axis. So if you looked at simply a point, and you wanted to, let's say that point is 9,3. Let's say it's 9,3. And you wanted to figure out the coordinates of a point that was symmetric about the x-axis. All right? So in other words, what point down here, if I fold it on this line, would that be? Well, we could see that this is the distance we would want to go. All right? So we would want to go that same distance. I didn't count right the first time. And here would be our dot. So if I folded, let's see, that would be same x-coordinate, but the negative of the y-coordinate. Such that if I folded along this line here, this dot would wind up exactly on top of this dot. Okay, so if you're symmetric about the x-axis, your x value is got the same sign, but your y value is going to have the opposite sign. Okay, so we could also talk about symmetry about the y-axis, so our fold line would be the y-axis. So perhaps we might have something like an absolute value function centered at the origin. Okay, you could see that if you folded along the green line, this line would lie on top of this line. Okay, so this function is symmetric about the y-axis. Or you could have something like a function that looked like that, which would be symmetric about the y-axis. If you folded it up, it's not drawn perfectly, but this line here, this piece of it, would lie right over top of this piece. All right? So what about if we were just talking about a point? So let's say we have this point here, 8, -4. All right? So I want to fold it on the y-axis, go over the same distance, so that if I folded it on that y-axis, that dot would lie on top of that dot. So what's going on here now is you can see that the x value has got to be the opposite sign, and the y value is going to be the same. All right, so that's what happens when you're talking about symmetry about the y-axis. The x value in your coordinate pair is going to change sign, and your y value is going to have the same sign. It's going to be along the same horizontal line. Okay, so that's symmetry about the y-axis. Okay, and the last case would be symmetry about the origin. So, of course, this is the origin here. So when we talk about symmetry about the origin, it's sometimes a little bit harder to see because it's really a rotational symmetry. So we're not folding up here. All right, so what happens is, let's say you have this dot here, all right, right along that line. If I rotated that dot, so what I've done here with these green lines is I'm showing you how rotational symmetry works. So let's say I connect this dot with the origin right here with this line, all right, and then I go back this way along that same line, and then perpendicular 90 degrees I draw this line here. Okay, so these lines are perpendicular. So that means if I rotate this much, I've got 90 degrees in the clockwise direction. If I rotate this much, I rotate 180. Of course, this would be 270, and this would be 360, and I would have gone full circle. I'd be right where I am. Okay, so if you're symmetric, if this point has a point that is symmetric about the origin, I'm going to rotate, first I'm going to rotate 90 degrees, and I'll end up here. Let's see, let's make it red. And then I'll rotate another 90 degrees, and I'll wind up there. Okay, so if this point over here was 1, 2, 3, 4, 5, 6, 7, 8, 4, and this point over here is going to be -8, comma, -4. All right, and that's what we mean by symmetry about the origin. Okay, so an example of a graph that would be symmetric about the origin would be a cubic. So that means the cubic function is y is equal to x cubed. So let's say this is that piece of it, and 2, 3, 4. This is the other piece of it. All right. So this cubic function here, if you can imagine it rotated 180 degrees, what's going to happen is that this piece of it is going to wind up covering this piece of it. Okay? And one of the neat things you could try is taking a piece of paper, lying it over the top of a drawing just like this, drawing the cubic function on there, and then rotating the piece of paper 180 degrees, and you'll see that you can prove to yourself that it'll lie right on top of each other. The two branches, the two pieces of it, will end up lying right on top of each other. So in essence, symmetry about the origin is basically a rotational symmetry. So if you were asked to find a point that was symmetric about the origin, and your point given was 8, 4, this would be the point -8, -4 that was symmetric to it about the origin.